Alright, you guys. Right now, I'm going to teach you how to do MVP charts. What an MVP chart is, we use a mass of an object, its velocity, we calculate the momentum, and we solve some momentum or collision problems. What does it look like? An MVP chart looks like this. You can see on the left-hand side, we've got mass and velocity and momentum on the left, and then we have a before and an after here. All of that's important. And we use it to solve for collision problems. And it's step by step. So if I'm talking too fast, you can rewatch this video, slow it down, and we can remember all of our steps. Alright, let's see what the collision problem that we're working on is. A 2 kilogram red car moving at positive 10 meters per second collides with a 4 kilogram blue car moving at negative 6 meters per second. Okay, so we've got a scenario here set up. Let's see, what's the question that they're going to ask? What will be the final velocity of the cars after the collision? All right, this is an information-dense slide, but let's think about it for a second. We know that we've got a mass of a red car, we've got its velocity, we've got the mass of a blue car, we've got its velocity. Drawing it definitely helps. So this red car right here, it's moving to the right 10 meters per second. This blue car is moving to the left. They both have momentum. They're going to collide into each other. When they collide into each other, which one has more momentum? Is this red one going to collide and overtake the momentum of this blue car? Or is this blue car going to collide and overtake the momentum of this red car? One important thing, this collision is inelastic. The collision is inelastic. That means that they will stick together after they collide. So if the red car had more momentum, they're going to collide and then move to the right. If the blue car has more momentum, they're going to collide and stick together and move to the left. If they both have the same momentum, they'll collide and they'll just stay still. They'll come to a complete stop. They'll come to rest. And what's the question asking again? What is the final velocity of the cars after they collide? So not only do we want to know, all right, what direction are they going to go, but how fast? What will be their final velocity? Well, for that, we need to use an MVP chart. So this is what the chart looks like. We'll go about it nice and easy. Step one. Step one is fill in what you know. First things first, let's fill in this box right here. Do we know the mass of this red car? Do we know the mass of this red car? Yep, totally do. It's 2 kilograms. Let's fill it in. 2. Do we know the velocity of this red car? Do we know this velocity of this red car? Totes and goats, we do. It's 10 meters per second. So this is an easy step. We just fill in what we know about the collision. Fill in what we know. What else do we know? We know the velocity of the blue car, negative 6. It's moving to the left. That's what that negative means. All right, we've done it. Step 1 complete. Fill in what we know. Step 2, calculate the individual momentums of each object. So how do we calculate momentum? Well, we use this handy-dandy formula. P equals mv. Momentum equals mass times velocity. Do we know the momentum of the red car? The mass is 10. The mass is 2. The velocity is 10. The momentum is going to be 20 kilograms meters per second. And we're going to do the same thing for the blue car. P equals mass times velocity. Mass is 4. Velocity is negative 6.